Yeah.
All right. All right, this is the problem. You saw the graph. I explained to you the graph. I explained to you the process. I said the process was going to be the same for most substances. And this is what I'm going to do. Right? This is what we're going to do. We're going to start with negative 20 degrees Celsius water, ice. And we're going to heat it up to 120 degree gaseous water. Clear? Ice to steam. How much heat, and how do you do this? Can you just say, well, it's 120 degrees times the mass times the specific heat capacity? You can't do that because water has 3 specific heat capacities. Solid, liquid, ice. Yes?
Is the first one supposed to be negative?
Solid, liquid, gas. Sorry. Yes?
Is the first one supposed to be negative 20?
Where? Here?
No, TS, like the TS, TL, TG.
It's just 20 degrees. That's the total. Yeah, you could say 20, but I'll explain in a minute.
It's temperature change.
I'll explain in a minute. I'll explain in a minute.
Negative doesn't.
Okay? I'll explain in a minute.
Okay.
Okay. So you have 3 different specific heat capacities and also heat of vaporization and heat of fusion. In the next one, when I kind of wrap things up, I maybe should have done this prior, but I'm going to talk to you about what phase change really is. It has to do with potential energy. But I'll explain that in a minute. I just want to get through the mechanics of this so you can begin your problem set before spring break, okay? Okay. Rebecca finds this difficult. You're going to find it very easy in about 5 minutes, okay? I'm doing easy numbers. The mass is 1 kilogram. Easy numbers, correct? Yes? So, I have 3 temperature changes. This should be, I have the ice temperature change, which is 20 degrees. The water temperature change, or the liquid water temperature change, is 100 degrees. And the gas temperature change is 20 degrees. Do you understand that? Now, those are total. Laura asked, well, should that be negative? Because it was negative 20. So, no, you just absolute. And I'll explain that in a minute. Okay? All right. Remind me if I don't explain it. Okay. So this is going to be, remember, mass delta T C, right?
Okay.
Right? Okay. You're going to have to help me out here with the calculations, okay? So it's going to be, I'm going to leave off the unit labels, okay?
Okay.
Mass is kilograms. Degrees Celsius is temperature. Kelvin, same thing. Don't worry about it, same thing. Okay, Kelvin, degrees Celsius. And then the specific heat capacities, which are joules, Kelvin, and kilograms. And the Kelvin and degree Celsius will cancel. 1 degree Celsius, 1 degree, 1 Kelvin, they cancel. Okay, now, so 1 mass delta TC, right? 1, 20, specific capacity there, 2060. So you're going to do that for me. I'm going to come back to that, okay? This is going to be mass times that. So it'll be 1 times 334,000 equals. And then this was going to be mass 1 times 100 times 4180 equals. You with me so far? Just plugging in. Excuse me?
I got the first one for you.
Okay, wait a second. Let me just finish this. This is going to be 1, 2, 2, 6, 0, 0, 0, 0 equals, and then the last one would be 1, 20, and gas would be 2020. All right, now, the second one is easy. That's going to be 334,000. Okay, that's an easy one. Let's move that over a little bit, shall we? Okay. Okay, you ready? Okay, this will be 333. Sorry. This will be 334,000 This one will be 2260,000. And what's the first one, Mike? 20 times 2060 times what?
I got 441,000.
400, wait a second. 441,000.
320.
320?
Yeah.
Okay.
I don't know.
320. Do we have any verifications on that?
Give me a second.
Yes, I'll verify that. I did that by hand.
Yeah, we need the verification. I just don't want to
Oh, wait.
walk away and have
Did
it.
you get this?
20 times 2060.
Yeah.
What
It's
is-
41,200.
Oh.
41,000.
Brian Markowitz, please come to the main office. Brian Markowitz to the main office, please.
All right, so that's okay. Do it again. 20 times 2060. What do you got?
41,200.
41,200.
Yes.
Good. Now, 100 times 4180. That'll be 4 million.
No.
Just throw 2 zeros.
180 zero. Is that right?
It's just 3 zeros.
Just 3 zeros?
Yes.
Yeah. Because if you multiply by 100, you start 2.
By 100, not 1,000. Right, exactly. So it's going to be 4180
0.
and 2.
Yes.
Okay, clear?
Yeah.
And then 20 times 2020. 20 times 2020.
It's 40,400.
Right? Yes, you got that so far? Add these up. What's the sum?
A lot.
Okay, well can we come up with a value? Okay, 41,200, 334,000, 418,000, 2,260,000, and 40,400. And I need 2 people to get this. While they're doing that calculation, I'll review what we did. This is heat 1, heat 2, heat 3, heat 4, heat 5. It's going to be mass delta T, specific heat capacity of solid, mass times heat of fusion, etc. I think we have an answer. Do we have an answer?
Yeah. It's 3,093,600.
3 million. Let me write it in a different color. We'll write it in green. What is it?
3,093,600.
And what are the unit labels? What are the unit labels? What are the unit labels?
Joules per kilogram Kelvin.
No.
I don't know.
No, okay. I mean, yeah, okay. All right. You know what? Can you remember that number? And we're going to go over what the unit labels are. We'll do a little dimensional analysis. Okay? I want you to put that in your pocket. And I'm going to put on a third one, and then we're going to clean everything up. Clear? Is that good? I want you to, and while I'm away, setting up for the next film, I want you to re-add that, okay? All right, to make sure that that's the right answer, okay? Then we'll come back and we'll clean things up. Excellent.
I'm leaving.